say hi. Hey, Mark, can you hear him in the back?
Test 1, 2, 3. Test.
You guys got it?
Testing.
All right. So it's about 10:30. Good morning, everyone. My name is Brendan Folks. I'm one of the Healthcare Solutions Executive at IBM. My job is the easy part. I just get to intro Mark. The nice thing is I have some background working with, Mark Aretha and the rest of the Michigan team, putting together this innovative project that Mark's going to describe with the Michigan Institute for Critical Care Research, MCIRCC. Along the way, the great thing that happened is I became a true blue Michigan fan, thanks to Doug and Mark and all that stuff. That's the amazing blue tie for the intro today. But this is really great. Some of these innovative things that we're doing to actually help patients. We talked about an analytics journey through a lot of healthcare sessions this week. We had Dr. Srinivas in from Medical University of South Carolina, folks from Health and Hospitals Corp, and we look at that idea of once you get your foundation in order, how do we evolve and climb up the chain and start to get from just basic reporting and analytics into predictive and prescriptive. And this is a really innovative use case around predictive analytics and what the team is doing to really affect care in real time to save lives. So this is a really exciting thing. With that, I'll just get hand it over to Mark because he's got the real content. Away you go, sir.
Awesome. Well, thank you so much. Thanks for having me, IBM. Thanks for showing up. I know it's getting late in the conference, and I know that sometimes the batteries start to wind down a little bit, and so hopefully we'll get you charged up again. We're really excited about some of the work that we're doing, and I want to share some of that with you today. So again, my name is Mark Salamango. I am the CIO for a group within the University of Michigan Health System called MCIRCC. And so I do CIO type things, but really what I try to focus on is looking at the business problems and grabbing those business problems and matching them with technology solutions. So a lot of that involves working with clinicians, doctors, nurses, looking at what their problems are, and figuring out ways that we can take the technology that we have and some of the smart people that we have and kind of put them on those projects. So I'm bridging gaps. I'm a gap bridger. So about this talk, I'm basically going to break this talk up into a couple different sections. So I'm going to give you a little bit of background about Michigan, about MCIRCC, about how we got started with this project. Then I'm going to talk a little bit about the project itself, which we call POCI. And I'll tell you what that stands for a little bit later. And then at the end, I'm going to give you some thoughts, some recommendations, some things that we've learned. Hopefully that will be helpful for you in your journey, whatever that may be. And then we'll do some questions at the end too. So if we don't get to all the questions, I'll hang out afterwards and you can help me with them. So a little bit about Michigan, if you don't know much about the University of Michigan Health System. We're a wholly owned academic medical center. We have 3 freestanding hospitals. We have over 1,000 beds, 66 operating rooms, and over 47,000 admissions per year. We also have 1.9 million outpatient visits each year, 160 different clinics and health centers, and 26,000 employees, and we're an epic shop for our electronic health records. So MCIRCC stands for the Michigan Center for Integrative Research in Critical Care. It's a mouthful, I'm happy I got it right. So what we're really focused on is doing research in critical care, right? So what is critical care? It's really, you woke up, things were fine, bad things happened to you, right? And it turns out critical care is a very expensive proposition. It's, the national statistics are total hospital costs are about 40%, at UNM it's closer to 50%. So there's lots of different critical care events that happen, and you know what? I'm not going to do this. I'm not going to put a whole bunch of text slides on. I'm going to just talk to you, make it real. I've never done this before. This is my first time in Vegas. You're in Vegas, you go big, you go home, right? I've been here like 5 days. I haven't seen a freaking show. And so I'm thinking it's about time, we change that for you all right? Are you cool with that? All right. So we're going to just imagine this is me and my closest friends on the planet. We're going to have a little fun, all right? Now this could go really wrong, or it could be absolutely fantastic. You're going to call your friends, you're going to tweet. I'm at Shred Factory. And anyway, we're going to try something here. So you got to use your imagination here, okay? So this is going to be a little tough. But you have to imagine that I'm a doctor. And it's a stretch already, right? Doctors don't dress half as nicely as I do, right? Okay, so I'm a doctor, we have a patient, right? So our first patient walks in, and our patient has a sprain, right? They're walking on the street, sprain their ankle. No big deal, they come in the ER to get checked out. We have another patient walks in, right? They have a fracture, right? They broke a part of their upper limb. And finally, the third patient comes in, and they maybe slam their hand in the door or something, right? So they have some kind of contusion in their hand. So now, as a doctor, I have to treat these patients. And since these are all pretty simple kind of conditions, it may not matter the order in which I treat these patients, right? It could be, any particular order. I'm not really worried about anything bad happening to them. So I'm going to start treating these patients, right? So I'm treating these patients, and there's only 3 here, but in reality, there's usually going to be lots more, like 20 to 30, right? And if they're this easy, do this pretty much all day, right? Piece of cake, right? No applause. So that was a pretty easy case, right? We could handle that. Now we're going to take a couple other patients, right? So we got a patient walks in, spondylosis, right? Complaining of some back problems. Another one comes in, you know what? Got a little bit of abdominal pain. Had some fish at lunch. Haven't really felt very well since. And so I come into the emergency department to just, check out what's going on. Finally, we have a patient who's got some non-specific chest pain, right? Their chest isn't feeling well, and it could be indigestion, it could be something much more, much worse. But the idea is they want to come in to make sure everything's okay, right? So I am a doctor, right? And I'm going to take care of these patients. Right? Everyone's still with me? Yeah. You enjoying the show so far? Yeah. All right. Right, so here we go. Okay. I'm an awful doctor, right? All right, we'll try this again. Oh, okay. And you know what? I know what the problem is. It's the jacket. I have to be able to flex. Where does that? Oh my gosh. Usually I would hire someone to take care of that. Hospital. All right. We're good. It's the light, I think. Okay, so I can do this. I practiced this very hard. Practiced for months actually. So I know I haven't done it in front of a crowd like this. Usually I do it in front of a mirror. So I'm going to try something. Okay? We're going to, this is crazy, I can't believe I'm doing this. I need a little help. I need a mirror. Would you help me out? Would you do my mirror? Okay, this is a little goofy. So my name's Mark. Jacob, good to meet you. This is Jacob. Hey, okay, so Jacob's my mirror, okay? You're almost as tall as me. He's almost wearing the same thing, too, so this is kind of like the way you dress. So basically, you're going to be my mirror. You have to do what I do, right? Okay, so let's just try this out, right? Okay, good. Sure. Good mirror, right? Alright, now I'm going to juggle looking at the mirror. Right, ready? That was pretty bad. Let me try this again. Alright, I'm going to juggle. You got to be a better mirror this time, right? Okay. Alright. So clearly, Jacob is a better doctor than I am, right? He's a much better doctor than I am. It's fantastic. Well, okay, so Jacob. Alright, so Jacob, you take care of those patients. You're doing such a fantastic job. How about you grab the guy that had, let's say, the chest pain, and you send him over. All right, cool. Thank you. All right, so Jacob has looked at this patient very well, I guess, and the patient's doing well. So the idea is he's going to just put him to the side. He's going to keep working on these patients. And basically, this person's just going to be for observation. The problem is, sometimes you are not observing someone and something will happen to them. So unfortunately, this patient with the chest pain is now becoming hemodynamically unstable, right? And so, let's see how good of a doctor we have here, right? Okay, so now let's see if this doctor can handle this patient who is now in an emergency status, has to take care of these patients, right? Okay, all right, so he's got it. Okay, so Dr. Jacob is taking care of all these patients, and he's got this guy stable again, right? He's feeling good. He was good. Okay, so I'll take him back, and you know what? I want to give you the other patient back, right? Okay, so again, he's taking care of him. But you know what? Now I need the abdominal guy. All right, cool, thank you. Poor abdominal guy is developing a GI bleed, and this is really bad, right? So the abdominal guy has got a GI bleed. So I'm a really good doctor. All right, so Dr. Jacob, let's see what you got now. All right, give it up for him. He's a fantastic mirror, doesn't he? So I'm going to take the doctor's stuff and I'm going to throw it back in here. Thank you, Dr. Jacob. Sure, no problem. I'll let Jacob go do what he does best. Okay, so this was kind of a silly example, right? But really, the truth of the matter is doctors are doing this kind of thing all the time, right? They're juggling patients. They don't always know which patient they should handle in which order, right? So just like we saw, it's abdominal pain. Maybe, the first assessment was they, just had the flu or something like that. The truth is that a lot of times these things are masked, right? And so when you go into an ICU especially, if you've ever been in one, you notice that there's lots of different sensors, lots of different devices. If you look at an EKG, for example, usually they'll have a 12-lead EKG on a patient, right? So you got 12 leads spitting out data at 240 hertz, so 240 data points on each lead every second adds up to a lot of data. Then you add things like pulse oximetry, blood pressure, medications, labs, and all the other things that we're measuring in the hospital, and it turns out to be a lot of information. Now, if I'm a doctor and I walk into a room and I look at that 6 seconds on an EKG, maybe you'll see something if there's an arrhythmia, but the fact is there's lots of little cues that are happening in the attention, okay? And then on top of that, memorizing which medications each of your 30 patients are on, knowing what their lab values are, all that stuff, it adds up to a lot of information, right? Too much information. So our vision was collect all that stuff. It is to collect all that stuff, to use all that data to make predictive models, use machine learning so that we can train these models so that we can make predictions about how patients are going to do. Seems reasonable, right? Cool. All right, so how did we get here? So let me tell you a little story about some work that we did. We got some healthy soldiers, put them in a torture chamber. No, that's not a torture chamber. It's actually called a lower body negative pressure chamber. And what it is it's a chamber that locks your bottom extremities in, and gradually they add lower pressure to it, or negative pressure to it. And that negative pressure basically sucks the blood from your top half, pulls it into your legs, and it simulates having hemorrhage. And the way that this worked is, these are all healthy subjects. They had EKGs on them. They were taking blood pressure, all their vitals. And they started with 0 negative pressure to get a baseline. And then every 5 minutes, they would crank up the negative pressure. And so over time, it's sucking more and more blood from your top half, right? So now their legs are like hugely full of blood, okay? So one of the things that we learned from this data was that we have 2 EKG signals. And it's very, 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 very difficult to tell the difference between which one's abnormal and which one's normal. In fact, one is abnormal and one is normal. Doctors can't tell the difference. They look exactly the same as the baseline, okay? So what we did is we took that information and we pulled it into the frequency domain, which looks like this. So we thought, okay, is there any difference here? Well, they look virtually the same too. So we can't tell, even from this, which were bad patients and which were good patients at which time. So we thought, okay, what if we extracted different features things like heart rate variability, all kinds of different mathematical things that we could take out of these signals and do some signal processing on them, and start doing machine learning to build a model that can make these predictions. And so one of the features that we came up with looks a little like this. And so if you start taking the average of this feature, you can see they're doing pretty well, and then they start to drop off, right? This red line is where intervention happened. So this whole point right here, all the way down, is about 2.5 hours of time when the patient was doing poorly, but when you're looking at their vital signs, you couldn't tell me. All right, so we train this analytic, and it starts to make these decisions. Everyone with me? So let me give you an example. I'm going to show you AHI in action. So I'm going to jump up here real quick, where I got my flaming torches to juggle. All right, so I'll jump down and walk you through what you're seeing here. So this is a real patient. This is a patient that walked in, was in the emergency department, and had a GI bleed. Thought he was stabilized, and what you're seeing here is this gauge up at the top is a predictor. It's saying we predict that he's going to do pretty well in the future, right? He's in the green. Down here, this is telling you what his current status is. So his current status right now is he's doing okay, right? He's in the green. And what you're seeing is each one of these ticks is 2 minutes. So this whole thing is 8 hours worth of data. Okay, so he's really doing pretty good. He's fine here. And this is kind of a longish video, so I'm going to scooch ahead a little bit, but I just wanted to give you an idea of what you're looking at here. So again, we think that he's predicted to be stable for at least the near future. He is currently showing that he's stable. So let me skip ahead a little bit so that it gets a little bit more interesting. So let's go. So even here, if you look at what's going on, the gauge has been predicting that this guy's not going to do well in the future. I can't tell you if it's 2 hours, 8 hours, 6 hours. At this point, we're working on that. But over time, the more our analytic is saying bad, 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 this starts to go down more and more. Okay? So you can see he's in yellow now, which yellow is kind of a moderate section. Below that is an orange line, and then below that is red. So we're still trending that he's in this negative direction. So we're telling doctors, please intervene, please intervene, please intervene, and no intervention is happening yet, right? Not to say that the doctor would know how to intervene depending on what the particular problem is, but now you can see he's in the red, he goes back up to orange. Again, this is the current status. This is where intervention was given at this point. So that thing was predicting a problem for over 2 hours in this case, right? So the trained analytic has been able to make a decision before there was any visible sign that position is. All right, so I'm going to show you one more case. All right, this one starts off the same, right? Looking good. And now, a few hours in, this is 10 hours worth of data. A few hours into the thing, we're already starting to make predictions that this patient isn't going to do well, right? He's already in this moderate kind of category, this yellow category. And we're starting to say that there needs to be intervention. So this guy, former cancer patient, had been treated, had been cured, came into the emergency department, had a little bit of a labored breathing, right? So on exertion, he was having a little trouble breathing. We set him aside, they were doing some tests, they thought he was pretty stable, right? Our analytic is showing, again, be careful, we think there's going to be a problem. And as time goes by, even here, he's in moderate, so for us, it's like intervention really needs to happen here. Right? This is one of the categories where we know something should be happening. And it stopped. No, it's still not okay. So again, each tick mark is 2 minutes. Each time it jumps once, it's 2 minutes. So I sped it up because I didn't think you wanted to sit here for 10 hours to see this thing go by. One of the reasons we designed the interface like this, and this is just a prototype interface, is because when we talk to doctors, they'd say, if we're walking down a hall, we know exactly what to look at to know if we need to go in or not. So they wanted something big along the bottom that would say, you know, this guy's in trouble, or this is, you know, the guy's fine. So you can see it dropped to red, and this is where intervention was given. So again, this is a few hours before the guy crashed. This particular guy died, right? So he was given code drugs, he was given epinephrine, milligram of epinephrine every 3 to 5 minutes, the typical code procedure. So again, not sure if we would save this guy, but we have lots and lots of examples of patients where our analytic has made these predictions hours in advance. In fact, one of them that I didn't do a video for, guy starts to crash, start giving him norepinephrine. He starts to come back, so they start titrating the dose down, where our analytic is saying, don't titrate down, he's not fine yet, don't do it. So they titrate down, he crashes again, so they titrate back up. And it happens 5 times, where we think he's fine, he's not. And all along the whole way, our analytic is saying, he's not fine, he's not fine, he's not fine. So that's a little bit of AHI. Again, AHI stands for Analytic for Hemodynamic Instability, and that's what we're looking at. We're looking at the hemodynamic stability of the patient, and really that just means is blood flowing to the organs properly. If they become unstable, it's not perfusing properly. Cool? All right, so let me switch back to the presentation. God, I wish I had another juggler now. All right, so how do we do this? How do we make this analytic work? It's probably what you're all interested in, not the juggling or any of that kind of stuff. It was wildly entertaining, though, right?
So are the doctors now, you're proving to them that this can predict, or they starting to adopt this more?
Yeah, we have a cohort of physicians that are really on board. It's going to be a change management issue, really. They're going to have to see it working for a while. So a little later, I'll show you the continuum of the project that we have, and where we are planning to move it out into more of an official rollout. So.
Is the data for your same as
It is. In fact, our first phase of this just uses 1 lead from an EKG. So the idea, when we see the continuum, is we're starting in the ICU because it's the most, they have the most devices and then the most data in there. We look at the emergency department and general beds and home. We have a partner that makes patches that you put on your chest and it'll measure your EKG. It'll send it to your phone and send it to us so we can monitor that in real time. I'll show you how we're going to do that in a second. So the question you're all asking, kind of beat me to the punch on some of this, but how is this possible? Right? Well, with big data, of course. Right? See, that's the big data. Sorry. So I'm going to give you, this is like the first tutorial I'm going to give you here, a recommendation. This is not big data. A lot of people think that you're going to buy like this TV dinner, and it's going to come prepackaged, and you're going to have your little vegetable, and you're going to cellophane, and you're going to pull it off, and you're going to put it in the microwave. It doesn't work like that. Really, the way big data works is more like this, where you're going to go shopping, you're going to clean things. This isn't the elegant part, right? This is the dirty, nasty stuff that is data science, right? I mean, pulling data in and normalizing it and munging it and transforming it and loading it, it ain't sexy, but it's something that has to be done, right? And you need people that can do that. So that's the first thing. Not this, no matter what anyone tries to tell you. It's more like this. And that can be glamorous too. In fact, this is our data stack. This is our stack line. We've only purchased a couple of these pieces, and I'll show you in a second. So there's this piece, the Matisa box, as well as Big Insights of the PDA. And there's a piece up at the top here that I'll show you in a little bit downstream. All this other stuff is stuff that we've had to home grow. And there's a lot of things. I'm not going to talk about all these things that we've built, but I'll give you a few of them. So, and we name them all goofy things, just so we're keeping in step with the way the new works. So Tater is an application we built to allow physicians to annotate waveforms. So they're looking at EKGs and they're trying to figure out what's good, what's bad, and that's what we feed into our machine learning algorithms. Groundhog Day allows us to capture these waveforms and play them back through our analytics, so it's kind of a repeat of the same thing over and over. We have things like Winch, which pulls data. So all kinds of different things that we've created just to make this platform work. Okay? So here's our architecture. We break it up and the way we think about it into real time and research. Real time is obviously, it's in the hospital room, we're collecting this stuff, and we're kind of making our assessments, giving that information to doctors. And then there's the research side where we've collected data, we're taking that, and that's what we're using to build the models and to train the analytics. So we'll start with the real-time side. So it's very simple when you draw it like this. To implement it in a hospital, not so much, but so we have patient monitors. We're a GE shop, so we have all GE monitors. We're using something called the CareScape Gateway here to pull all that data and kind of aggregate it. Again, Epic is our EHR. We pull it into a streaming engine, which I'll talk about in a second, and it gets output to AirStrip, which is another thing I'll talk about in a second. Okay, so looks real simple here. Let's talk about the streaming engine. Really, there's two that we're using right now. So there's InfoSphere Streams, which some of you are probably familiar with, and we've also been experimenting with Spark. And the idea is we want to know where InfoSphere Streams is better and where Spark is better. So as we scale this to the enterprise, we can make better use of the particular strengths that each one has. And then we're using a product by a company called AirStrip as our mobile device aggregation display. If you saw the last Apple event, AirStrip had an app on the Apple Watch that was doing like fetal monitoring and pregnancy monitoring, things like that. Great little company. So the way we deal with this streaming information is we have data comes in from the monitors, and we build these things called operators. They're called operators in InfoSphere Streams, so that's what we kind of call them in all of our products. But there's all these different operations that we do on this data. So we deal with something called baseline drift. When you have the signals, they don't look as pretty as what you saw on the screen. They're usually moving up and down and doing all kinds of crazy things. As you move as a patient, it introduces noise, so we have to filter that kind of stuff out. So all kinds of filtering we have to do. And if you've looked at EKGs before, you know how crazy it is to try to make sense of them and normalize them so that you can make some decisions based on it. But at the end, we end up with a model. Out of the model comes this AHI score. Okay? The AHI score is basically the prediction of how they're going to do in the future, and then we give a score about how they're doing right now. Okay? So here's a display just from an iPhone of what the AHI score looks like in the AirStrip. So you have a score here of 2, and they're trending upward, so that we know, hey, okay, this guy is going in the upward direction. Okay? The way AirStrip works is they also have vitals. They have real-time EKG feeds, so on the golf course, if you're a dog, oh yeah, it's got going tachycardic. I guess I should hit my 3-iron. So our research architecture, though, looks very similar, but I want to talk about a couple of these pieces. So again, patient monitors, and go to this CareScape Gateway, which is really like it's kind of like a router, right? You're getting data from all these different devices, it gets collected there. Again, it goes into the streaming engine, and then it goes into something that we call CIRCC. I'll tell you about that in a second. And we also have other data sources, health system, data warehouses, all kinds of billing, finance, things like that, all get pulled in as well. So the interesting thing here to me is CIRCC. And CIRCC consists of a couple different things. So CIRCC, because we're dealing with waveforms. So it consists of these two pieces, the period for analytics, or Netiza, and Big Insights, which is the Hadoop. And what we found is that we're making use of both of these things. And so we thought, it would be really interesting to put an abstraction layer in front of those so that it's really easy for a doctor who wants a patient with data from this time to this time. CIRCC manages all that, goes to Netiza for the discrete pieces. It'll do some calculations, pull that stuff back. It'll go to the waveform repository, which we have in Hadoop. It indexes the pieces of those waveforms and just pulls what the doctor needs. So we call that CIRCC. We have a whole bunch of services that we've written on top of it. We intend to sell it back to IBM at 10 times the cost of all the stuff that we've bought from them. No one? Come on.
I can sell this.
You can sell it? All right. And I'll be quitting you event shortly to start up with a company with Brandon. So that's CIRCC. So the way we've structured the project, fall of 2014, we made the purchase of a couple pieces of RDM hardware and software. So again, the PDA, the Big Insights, InfoSphere Streams. So we have a bunch of boxes and a few racks that are pretty impressive looking. In the spring, we started working on retrospective data. So we collected data, different departments have collected data for like 3 years. And so we found cohorts out of that, those people to help train the analytic that we have right now. We built what we're calling the virtual big data team. So MCIRCC is a small group that has affiliations with about 130 other people within the university. So we got computer science, engineering, clinicians, biomedical. It's all these different groups are members of MCIRCC. And we thought, you know what, we have a core team, but we need additional help from some of the database administrators, sysadmins, things like that. So we basically have this virtual team that we call the virtual big data team. So with that team, we're building these custom tools and we're managing with different devices. In fall, physicians started annotating waveforms, and then we started building these metrics. First analytic pipeline is basically complete at this point. So what you saw were things that we were running through manually. I don't know how many people are from health centers and hospitals, but it's a very large organization that I won't use the bureaucracy word, but it's sometimes difficult to make these things happen. So, so we have now connected everything together and data is streaming. We're starting to move the project to 175 ICU beds. And then in the summer plus, we're going to do that expansion to move to the emergency department general beds and home. So all these foundational pieces have been put in place, and now it's just executing these things down. All right, so a quick note about how we got this far. Again, big company, big organization. Things aren't always easy to do in these big organizations. The way we made this happen is we found a team that was motivated, right? This is how you get things done. You find people that are motivated to do something, they're passionate about it. So we were shameless in stealing from every department we could steal from. And we were happy to do so. And in most cases, those people were very happy to come and join us on playing with the new hardware. So that's kind of one of the things, if you're going to try to do this from scratch, that I highly recommend. Instead of just taking the people that you have and saying, okay, now you're going to do this, look for people that are really passionate about the work and what the possibilities are. And then what helped us is we focused. We had a team that focused. I don't know how many of you are multitaskers, but we know that context switching, there's often a penalty. There's always a penalty. So what we did is we took a team, we set them in a room, and we said, this is the goal, this is what we're going to work on, and we're going to focus on this particular thing. And so we've given these, it's not a team of 30 people, it's a team of 5 people that what we do is we focus on this problem. Okay, and then where we need to pull in help from other groups, we pull in other groups. The other thing is, when you have the team, you want to make sure that they have the right skills. And so I look at data science and the kind of work that we're doing a little differently. Some groups are super huge organizations that can afford to have a group that just does development, a group that just does this, and a group that does this. We're all jacks of all trades on our team. So we have people, pretty much every one of us are database people, we're developers, we're analytics people, we're data scientists. There are some of us that go a little deeper than others, but you better have people on your team that can write some SQL, that can write some code, that know how to administer a box. Those are some, so it's a good team, solid performance. And so this is, I guess, maybe my biggest recommendation, and then I'll kind of shut up and you can ask some questions, is that if you're going to do this big data thing, I think the whole if you build it, they will come thing does not work. You can buy all the gear on the planet, and it'll sit there, and it'll look awesome. I mean, IBM black color is fantastic. I mean, it's great. I mean, having the refrigerator-sized units, and I can't tell you how many people I've chirping by to our data centers saying, these aren't they cool? Open them up, look at all the hard drives. But the reality is, if you don't have a use case to build your big data strategy around, I don't think you have much of a success of being, or much of a chance of being successful. So that's the recommendation: is find something, find a problem. Often it isn't the most crazy, difficult problem on the planet. I know a lot of times we shoot for the stars, but there's low-hanging fruit all over the place to use analytic technology for. So that's the recommendation if you're looking at those. So I'll ask if you have any questions.
When you were looking at your big data, was there a particular pain point you're trying to accomplish with storage, MVP,
So when we go back to what the problem was, so with the healthcare system and the way it's working right now, we can't afford to have patients coming back, right? It just costs too much, right? So we thought, okay, this is the problem, is that we want to make sure we're delivering better care. How do we do that? Well, we have all this data that we're not using, so we could put it in Oracle, which we have. We could put it in any of the other SQL Server or whatever, DB2, one of the databases that we have. But when we started talking about streaming data, live streaming data, it became a problem. Everything else was breaking down. So again, when we have 12 leads on an EKG, 240 hertz on each one of those, then we have 120 hertz on pulse ox, we have 50 waveform signals that are coming in. We had to start thinking, okay, what are we going to do with this stuff? How are we going to feed it in somewhere? I mean, we could dump it into Oracle. We could try to move it around. We could try to do some work with it, some queries, run it through some kind of a machine learning. And then, 2 days later, we'd have an output, and the guy would already have been dead, right? And so we needed something that was going to be super quick, something that could land structured data as well as unstructured data. And so that's kind of why we started going this way. Besides waveforms, which technically are structured, we kind of view them as more unstructured data. We're collecting images, so we have CT scans, MRIs, all these different things where we have our analytics team doing image processing on to train other algorithms to deal with these things. So it just kind of made sense for us, the speed, the fact that these things are more scalable. It's just kind of what we're doing. Yeah.
Can you share your experiences on where you see the greatest
So we're learning that right now, to be honest. So when I showed that picture of the pipeline with the filtering and baseline drift, we have all that built in streams right now. So a lot of our analytic initial work was done in MATLAB, and we needed a way to take that analytic, wrap it in something, and then test it out. And for a while, we were struggling wrapping that MATLAB code into streams. There was a bit of a bug in the way the MATLAB compiler was working. And so we worked with MATLAB, they fixed that bug. And so as we were running into this problem, we said, uh-oh, this could be a bad thing for us. So we started exploring Spark, and we started building those same things in the pipeline. The goal is to run them at the same time and see which is better. And we haven't gotten there yet. So we've gotten to the point where the pipeline's been built in streams. It's not completely built in Spark yet, but that's where we're going. So I have one guy working on one, another guy working on the other, and it's a big competition between the two to see who's able to handle more data. Spark is free, but I always say it's free like a puppy, right? So yeah, you get this thing and it's free, but then you don't have support, and if you have a team of people that can deal with that, then that's great. We're a startup, and that's one of the reasons we started with all IBM products, is because we wanted to prove this stuff out in an environment where we knew things were going to work and play together well. So that's kind of how we started. So I don't have a great answer for you. In another couple months, I will be able to tell you, I'll call you up and say, hey, Fonny, this is what we found. Streams is awesome for this. Spark is better for this. Spark, there's a little more latency when you're doing a lot of data, whatever. So I'm happy to share that. Yeah, right. I'd love to have 60 more patients up there, all the lives we've saved. I mean, really, this was retrospective data, so we haven't released it into the wild where patients are, physicians are looking at these things and saying, you know what, I'm going to look at that and maybe treat the patient. Yeah, so our executive director is an emergency room doc, and he did a lot of work with setting up projects for the military and critical care for the military. And this was just something he was passionate about. Hemodynamic instability is kind of a general term that people can be dying of sepsis, they can have all kinds of different problems, and they just become unstable. And so the idea was this is kind of a bit of a catch-all for a lot of different things, and so we thought if we could solve this problem, it would just have awesome ramifications down the line. And because that lower body negative pressure stuff was done with EKG, which is simple, right? I mean, you can almost have them on phones and things now. It seemed like a good place to start. And so once we started proving some of these analytics were working, we thought, okay, we need to keep moving. We're on the cusp of something amazing. Yeah. Yeah, I was joking. I hadn't thought about it too much. I was teasing some of the IBM folks a few months ago, saying I had something big that I wanted to share with them and explain what we were doing. And I hadn't really thought about selling it, but or giving it away. I mean, that's something that we could decide to do. I think it would be awesome. I mean, we're helping other groups with integration to Epic, which isn't trivial. You know, integration to any EHR isn't trivial, right? There become issues. And so we're happy to share a lot of that knowledge. It's helping patients. I'm good with that.
I have a question about how does Epic, what part does Epic play in this system?
Yeah. Yeah, so right now, that's all it is it's a store, right? So medications, labs, all that stuff, that's where we're pulling from. We're pulling from Epic. Waveforms, we're grabbing on our own, and we're doing our thing with it. But most of the discrete stuff, demographics, BMI, you know, all that good stuff is coming from Epic. We're not sending it back to them right now. We have another database that sits and collects the AHI scores and then transmits it to Airstrip to pull the scores out. If at some point Epic wanted to somehow, you know, pull our AHI score into a pane or whatever, I don't see that would be a problem. It'd be easy enough for them to make an API that we could write to. That's all we're using it for right now.
The thing you've got in place now is an indication of some sort of invention.
Yeah.
How long before, and what do you think you would need to do to get to the point where you're able to do an invention?
Yeah, so we haven't even started on that. That's a huge problem. What we're planning is we want to get this out into the wild, and then the thing that we're working on now is, okay, so we're saying he's going to be bad, but it could be 2 hours, it could be 30 minutes, it could be 6 hours. So we're starting to put like boundaries on it. So we're saying we think he's going to be in this zone in the next 2 to 4 hours. From the clinicians we've talked to, they're like, oh my gosh, if you could give us that, that would be insane. They're like, if you could tell us 30 minutes before something's going to happen, that's like, or 10 minutes, you know, whatever, all that is fantastic, because usually what they're doing is they're seeing the blood pressure spikes down, or, you know, the person doesn't look right, or, you know, they go into a systole or something like that, and then that's when they're reacting. So.
Two questions.
Sure.
We hear an awful lot about crowd in lots of different industries, but I'm not so sure there's an awful lot within healthcare. How do you envision this working with the cloud? One. Number two, you mentioned various packs and other fusion type systems. How are you getting the data out of them? And are you doing anything with the DNA?
Okay, so first question, cloud. I'm a big fan of the cloud. When I started this job 2 years ago, that's what I was pushing. I was like, why are we not clouding everything? There are still a lot of people that are afraid of the cloud and afraid of the security. I have some strategies about taking this and releasing it into the wild in the cloud, and I would really love to do that. That's kind of on my internal roadmap once it's been proved out, and we're really showing it to a lot of people. So I think it's just an adoption thing. I think healthcare tends to be a little bit behind the curve, and I think that's kind of that's the problem. I mean, it's just that healthcare is a little bit slower moving to adopt technology. I mean, part of it is FDA and certain pieces of technology, but a lot of it is just, I think there's fear. The second question was, help me. Oh, right. Yeah, so right now we're using ETL type processes to pull them in from, we use McKesson for our PAC system, so we're, extract, transform, load type things. We're using Endaho to do that right now. We could use basically anything. So it's largely a manual or batch type thing that we're doing right now. The idea is that we will make use of the APIs that are available to pull those things in more real time. And that's again why we brought the Big Insights thing online, is because we can organize those pieces in Big Insights very well. I'll tell you another thing that we did that's pretty interesting. Most people take waveforms and they just put them in a file system and they just kind of plop there, right? And then when you want one, like our waveforms are usually like 12 hours long, right? So if the person was there for the whole day, or they may be 12 hours or 24 hours long. And so when you want to do something with them, it kind of sucks to have to copy that whole file. So by plopping them into big insights, and we're using a binary format. So we know the resolution of the file, we know how many bits or bytes are along this little continuum. So it's very easy for us to just pull a section of these things. So it's very efficient, it's super crazy fast. In fact, when we put stuff into big insights and did it versus the file system, it was so much faster than anything else we've done that we thought, okay, we're on to something here. So there's another little nugget. You store these waveforms as binary files, and you can just do just basically do a calculation. I want from 8 o'clock to 10 o'clock, you just go, okay, that would be this many bytes. You just go, you use something called a seek, it goes there, and it's like lickety split, and it saves so much time, it's just crazy fast. So one of my guys, Dan Stewart, came up with that, and it was just a brilliant idea, and it immediately made everything really fast. So MCIRCC does that too, so I just gave you a little, I opened the kimono for you, you're welcome.
You talked about your time continuum for projects, where it is now and where you see it, extending it out to your general beds and even into the home. Can you talk about your vision for what you'd like to see about integrating that into the homes of your patients?
Yeah, well, so the idea is, well, first off, if I walk into a hospital in ED, right, it would be awesome to take that $3 patch and put it on someone, right, and just start monitoring immediately. Because triage is a huge thing, right? How many times you go to an emergency department, you see 1 million people lined up, and it's hard to tell how they're doing. You're not monitoring from anything, but if you have this EKG patch, it really could be a game changer. Likewise, once these people have these patches and they're hooked up, by using these AHI scores, we can start telling doctors, go to see this patient, and this patient, and this patient, and this patient, rather than the round robin kind of way that we're doing it right now. But at home, imagine, my parents are getting older. I would love it if they could wear one of these patches, talks to their cell phone, and it's always, every minute or every couple minutes it's sending data to our cloud. Our cloud is then, doing the analysis and spitting out what the results are. And you know what? It could get to the point where it's like, you know what? You're not in any immediate threat right now, but if you come into the emergency department or go see your doctor now, it doesn't become super expensive by having to put you right into the ICU. The ICU is the most expensive place you can be in the hospital, right? You have more monitors, more people dedicated to what's going on. So if we can catch people before they get to that point in that continuum, that's a huge savings, right? And that's what we want to do. So the idea is we can catch people at home hours before something's going to happen and say, hey, you know what? Don't be alarmed, just come on in now. We'll take care of you. You can see them in the emergency department and handle it. Does that answer your question, Ish?
Yeah, and I thought somewhere in our conversations before you're talking about too of like post-op care. Yeah. And how that might integrate with a project like this.
Yeah,
can you speak to that too?
That's another one. So one of the places we want to start testing this is post-cardiac surgery, right? So there's usually, after cardiac surgery, there's kind of a lull where people crash and then they come back. It's just a natural thing. That's another place where we can start monitoring to say, you know what, we think they're out of the woods now. AHI's showing green in the future, so maybe we're okay. Now, again, in the continuum, we're not looking for an FDA clearance on this right away. We're not telling a doctor what to do. We're just saying, hey, look, we think that in the future this person is not going to do so well. You guys take it from there for now. Now, in the future, maybe the FDA is what we're going to do, and we're going to give interventions, give them a bolus of whatever. But at this point, we're sticking to just try to make a prediction. Yeah, that's a really fantastic question, and we're working on real numbers for that right now. We're engaged with IBM on that very thing, because anecdotally, it's simple to see, right? If I can limit the stay in an ICU by a day, we're saving thousands of dollars. If we can prevent someone from moving, up the echelon of care, we're saving thousands of dollars. Every time, so there's this thing, basically, it's called like post-traumatic ICU syndrome or something like that, right? So if you've been in the ICU and you get out, you have like a PTSD thing for weeks, months, or years, right? So if we can keep people from going into the ICU, that seems like a pretty good thing. I mean, it's a scary place, right? All these things hooked up to you, people walking in and out. I've toured them, I work in them, and it's like every time I'm like, yeah, I don't like it in here, right? So if we can do that, that's going to save us. So we're working on it, but as with a lot of places, we have a finance department, we have this department, we have a silo of this and a silo of this, and so we're trying to grab all that stuff together. And it's just not always easy to see, even the data. It's like length of stay can be calculated like 9 different ways. So which one are we going to use to figure out the ROI, or the ICD 9 or 10 codes, or what? It's insane. Tony? Yeah. So we are using the clinicians to tell us, and that's what we're using to train the models. So that thing I call Tater, I can show you that at some point, but basically it allows you to pull in waveforms, and so you have a waveform at the top, and then along the bottom is the whole stay, and then it shows you every time they were given a drug, what their blood pressure was at each one of these times, and clinicians will look and they'll say, you know what, blood pressure's a little funny. They were given epinephrine here. If they were given epinephrine here, then something happened, right? And so they'll highlight that region where they're like, this looked bad, right? And so once they highlight that, we store that in a database, and that gets fed back into our training. So that's exactly how we've trained it. We've looked for these different sections of good, bad, ugly in the waveforms, and that's what gets fed into the training model. All right. So we're mostly a Java shop when it comes to doing the development work. Part of that is because that's my background, and part of that is because none of the guys on my team are bigger than me or fight as well as I do. I'm just kidding. So no, I mean, I believe in agile development methodologies, and so the thought is we're going to do these iterations, and if someone gives me a reason why we should use Python or why we talk about it. And there are little server bits that we've written in Python just because it's easier, and we're trying to harden things as we go. We're moving into a continuous delivery phase where we're checking in code every day, and we're doing the unit test for everything. But my philosophy has been do the simplest thing that could work, show that it works, get it in front of the physicians. And that's the other thing is we have physicians coming in a couple times a week to look at what we're doing and what we've done. Most of the time, developers are introverts and they want to just kind of stay in their own world. It's a team thing, and so they're constantly correcting us and saying, oh no, this drug doesn't do this or this. So it's worked really well, but we haven't standardized really on a platform except for we're using Java and Jenkins and those kinds of things. What's that? I'm sorry? A little of both, mostly Linux. Trying to think, one of our boxes for the integration to Airstrip is a SQL Server box. So, but all the development, come to think of it, is Linux. So it happens to be Red Hat right now.
So when you're on the intervention dash, is that something you're able to automatically get from the
Yeah. Yeah, so that's what we're using for Epic, or we're using Epic for. So every time a drug gets scanned, it gets thrown in there, and we get that. So yeah. I really wish it were, but a lot of times what happens is the drug will be given, and then you're given a code dose of Epi, right? I don't know exactly when that happened. It's sometimes within a couple minutes, sometimes within 20 minutes. That's what makes it really tough. So that's something that we're working on. I've been told over and over, there's no way you're going to time align these things perfectly. And that's another thing that SIRCC does for us. There are some pieces of SIRCC that helps us time align different waveforms, as well as ventilator settings, medications, labs, all that stuff. So, but that is one of the challenges we've come up against, and we've thought, you know what, we just got to do the best we can, and it may kill the fidelity a little bit. But. Any other questions?
Could you expand more on your machine learning, or if you take a vended platform and customize it right around, what kind of feedback loops are you including besides just clinical and that thing?
Yeah, so I can tell you some of it. So the general idea is we extract features from these signals, right? So you got these waveforms and we extract features. And one of the features that I didn't understand what features were at first, right, in signal processing. But the idea is one feature could be the distance between two R peaks in an EKG, right? And so we see the distance between this one is a couple milliseconds, this one is a couple milliseconds, right? So that's one feature. There are, in our model, there's something like 1,025 features that we're extracting. Different things like that. Heart rate variability, this over the mean divided by this, and there's all these different things. So what we do then is we look at ones that seem to be consistent with what we think is supposed to happen. So we'll narrow that down to like 100 different features. So we have 1,000 possible, we look at each one of them, figure out which ones are good, come up with 100, and then we start running this this cross-validation on these over and over and over. So we deploy that to our HPC center, it starts running the model, and then we go. Sometimes we have to tweak the variables of these different algorithms. And there's some of these features that we have we've written some papers on it, and we're getting ready to write some more that are completely novel things. And that's really what you were seeing up here is some of those novel things, the results of those novel things that I can't talk about just yet. But for next year, there will probably be a paper that goes along with that too. That's pretty cool stuff. So, beyond that, I'd have to have you talk to our PhD computer scientist, who's the real brains. I'm just the eye candy for the group. Yeah. Any other questions?
Neil?
Right.
Mark, thank you very much.
Yeah.
And this is where the slide's supposed to have to stand and go fill out your survey thing.
Oh yeah,
The end of
it
it
does.
was done.
We got it. I got yelled at by some legal people. Notices and disclaimers. Notices and disclaimers continued. And oh god, I did forget the feedback.
It's okay, don't worry about it. I'll come back anytime.
Okay, good.
Especially if you bring Dr. Jake and the Jugglers.
Yeah. Okay, thanks everybody.
Thank you.